Hello everyone, let's get the meeting started. Hello, good evening. All right, welcome welcome to the Recreational Astronomy Night meeting of the Toronto Centre, RASC. My name is Paul Markov. I'll be your host for this evening, introducing the speakers. And is it on? It is on. The microphone is on, indeed. And we have a busy evening ahead of us tonight. Despite this cold, rainy weather, we'll take you back to a warm, hot August day. We're going to be talking about the solar eclipse again. So we have 4 speakers lined up for that. Right after Blake does the sky this month. The 4 speakers talking about the solar eclipse are going to be Chris Jolie, followed by the Knapp family, and then Charlene Norgrove, and finally Dan Falk will round up the solar eclipse presentations. And then, assuming we have time, and I think we will, Ron McNaughton will give us a presentation called From Messier to Spiral Arms. Quick show of hands, do we have any new members or people who are here for the first time, members or not? Welcome. All right, I think we're good to go with Blake, the sky this month.
Thanks for having me. My name is Blake Ninker. I'm your tour guide for the sky this month. The time period that we're talking about, of course, is from today, so November 13 through the next Recreational Astronomy Night meeting, which I think is December 15. So my information here is talking about essentially the next 4 weeks, but we're obviously straddling a couple of months here. I've prepared my usual materials for this presentation. That is, I've got my month at a glance web calendar that shows icons, various activities on each day. The icons indicate the equipment that you might use to view it. I also have observing lists that I've prepared for popular astronomy applications, including Sky Tools and Sky Safari. I've also made just a general purpose list in Excel. And there's lots of external links. I have the web address for this article at the end of this presentation, but if you looked on the website now, you'd find all that information there now. So there's lots of details there. Everything that I'm talking about, including all the specific dates, are noted in that presentation. Starting off with the sun, it's curious that the sun is very active right now. It's surprisingly active, even though we're in a trough. You may know that the sun goes through a cycle anywhere from 9 to 14 years, and we're between solar maximums right now, but still we're getting these random interesting events with the sun, including very large prominences. I did look today that there hasn't been any sunspots for about 2 weeks, but we're still getting big prominences and coronal holes and occasional aurora and stuff like that. So worth looking at. In a day or two, sunset's going to be around 5 o'clock. Sunrise will be at 7:15, and that means that when you factor in astronomical twilight, where the sun is quite far down below the horizon, about 18 degrees or lower, that means we get 10.5 hours of darkness. Woohoo! I didn't like winter that much until I started really getting into astronomy, and then end of this time period on December 15th, we get 11.5 hours of darkness. Yes, so that means if you want to do lots of visual astronomy, you'll be able to do that, and if you're an imager, you'll be able to get lots of data. The sun is in Libra right now. It moves into Scorpius on November 23rd, very briefly, and the way the constellations are oriented now, it quickly exits that and moves into Ophiuchus for a few months. So that's interesting to note. off to the moon here. Tom pointed this out, and I've thought this too, looking at this image taken by Michael Watson with the sort of hazy cloud in the foreground. This reminds me of Galileo's early sketches through his early magnification instrument. The moon is new on November 18th, and that's good news because that's very near the Leonid meteor shower peak. First quarter is on November 26th. Now, the day before first quarter, there's an opportunity to see Lunar X. Anybody seen that? Anybody seen Lunar X or photographed that? So that's a little X-shaped pattern that's on the surface of the moon near the terminator between lightness and darkness. It just happens to be the arrangement or position of some craters in relation to one another. So it's a neat thing to look for. It's a very small feature, though, and you have to look at it at the right sort of time. On November 26th proper, there's an opportunity to see the railroad or the straight wall. This is a fault in the surface of the moon, and the lighting angle creates this very stark shadow, straight as an arrow, straight line in the middle of Mare Nubium. So that's something to try for on the 26th. Here's our solar system right now, or in a couple of days, if you were flying around in outer space. The Earth is here in the foreground. Sorry, let me back up. So Earth here in the foreground, and the moon's just beyond it. You can just barely see the moon peeking out on the right edge there. If we were to draw a line down through the sun and look only to the left, that's effectively what you're seeing at sunset. And if you look to the right of the sun, you'll see there's a bunch of planets there, and that's effectively what you're seeing at sunrise. Rhonda and I have been having these interesting conversations about sunset and sunrise. Those are actually technically not correct terms. It's the sun's not setting, the moon's not setting, the moon's not rising. We have been casually referring to these periods of time as the period of time when the sun rotates away from the sun. The period of time when the Earth rotates towards the sun. That's a bit of a mouthful. I'll continue to use the short forms here. But you can see Mercury is to the right of the left of the sun. It's obviously very close to the sun. It's always hard to see, but there's a good opportunity, fairly good opportunity to see it this month as it moves quite far away from the sun. The angular separation between the sun and the planet is near its maximum. We call that greatest elongation. That happens on November 24th. Who's seen Mercury with their naked eye? Lots of people, that's good. Very challenging to see. If you've never seen it before, it took me a couple of years to sort of find it. Go out with binoculars. Maybe if you have an app on your smartphone, that'll get you looking in the right direction. And it's very small. It's a pinpoint of light. It's star-like. And once you find it in binoculars, you can usually put the binoculars down and you can see it with your naked eye. The moon will be near the planet Mercury, on the 19th and the 20th of November. So that makes it easier to look for it, and that helps with your eyes to be able to focus the right amount. So that might be a good time to look for it here. The Saturn, you can see, is way off in the distance. There, Saturn is setting, falling into the sun. Well, it's not falling into the sun. Again, technically, the Earth is moving counterclockwise around the sun, and we're moving in such a way that the sun gets in the way. The sun is occulting Saturn in a short period of time. So this really represents your last opportunities to look at the ringed planet. So look at it while you can. Again, for the early birds, if you look to the right, you can see Mars is here. That's Ceres. We'll ignore that. But Mars is there, the red planet. Just to the left of it is Jupiter. They're rising about 3 or 2 hours before sunrise. Venus, which is very bright, is visible about an hour and a half before sunrise. and the moon will get very close to, a thin old moon will get very close to Venus in a couple of days on the 17th. So if you're an early bird, you can look for all those planets in the morning. I don't think anybody saw the very close conjunction or repulse that happened a couple of days ago. Anybody see it here? So I think people out in the East Coast saw it, but that was very nice. It'll happen again, but that's a somewhat rare event. So thank you, Chris Vaughn, for providing these images from Sky Safari. This is essentially what you'll see on November 20th, looking in the west after sunset or around sunset. And notice Mercury is below that yellow line. The yellow line is the path of the planets, or represents the plane of the solar system. And Mercury is inclined. It has a high inclination compared to the other planets. And unfortunately, that puts it below the ecliptic. And that means you're looking through more air. It's closer to our horizon. But hopefully the moon kind of over top of it will help you spot that. And you can see Saturn's in the picture there. And if we look the other way in the morning, this is the image from the 13th a couple of days ago, where Venus and Jupiter were practically on top of one another, Mars way up high there, but Venus will be dropping in the sky as it appears to get closer to the sun. It's moving more rapidly than we are, of course. So those are your evening and morning planets. Now, if we look the other way, there's the Earth again, and you can see that Uranus is almost directly opposite from the sun. In fact, Uranus went through opposition a short time ago, so it's relatively close to us. The distance, if you were to measure this in Earth-Sun distances, which is the astronomical unit, Uranus is 19 astronomical units away, which is quite a long distance, but it's relatively close to us, and that means it's around magnitude 5.7. And that's kind of the magic number for some. Magnitude 6 is about the limit that some people can see things with their naked eye. Anybody seen Uranus? Naked eye. So I saw that a couple of years ago when I was in Mew Lake in Algonquin Park. It's very challenging there, but it's an opportunity to try for that when you don't have any moonlight around. If you're photographing it, you might be able to see details on the surface of the planet. I also like looking at planets when they're at opposition because there's a better opportunity to see some of the moons. 3 of the bright moons around Uranus are Titania, Oberon, and Ariel. Ariel is the faintest one at magnitude 14.4. So that's tough. That you're going to need an 8-inch or a 10-inch telescope to see that. Very challenging. I think I've seen it once over many years. December 10th is a particularly good evening to look at Uranus because Ariel is quite far away from the planet. Again, we're talking about elongation. The further away the moons are from the planet, there's a greater chance to see them. Ariel is quite far away, which is the innermost faint moon, and Oberon is visible as well. So that's a good night to try for that. And I have a bunch of other dates of maximum elongations for the moons on the webpage article, so you can look those up. Notice Neptune way off to the right there. You should be looking at Neptune earlier in the evening as opposed to later. Both of these planets are near magnitude 4 stars, but Neptune itself is magnitude 8. So you're going to need at least binoculars to see that little pale blue dot. The fascinating thing about Neptune, though, is it's much further away. It's 29 astronomical units as opposed to 19, but you can see the moon, the big moon around Neptune, easier. That moon is Triton, and its magnitude 13.5. It's brighter than any of the moons of Uranus. So that's a good one to try for. Is it size? Is it because of the size or its albedo? I don't know why that is the case. So those are some of the objects in the solar system that I wanted to talk about. I also wanted to talk about this one. Did you hear about this? The fast mover object that came out of nowhere that initially was thought to be a comet, and then it was classified as an asteroid, and it was given the designation A 2017 U1, and I just read a day or two ago it's been reclassified as 1I. I refers to interstellar. So the interesting thing about this object is it came from out of the solar system. Partly you can tell by the steep angle that it's coming in from the the solar system. This was discovered by the University of Hawaii's Pan-STARRS telescope. It was measured at 400 meters. It was moving fast at 26 kilometers per second. That's about the same speed as the Earth moving around the solar system. You can see it zipped within the orbit of Mercury, did a hairpin turn, and then it got very close to the Earth, 24 million kilometers. Yeah. Or 60 lunar distances, the Earth-Moon distance, 60 lunar distance. Cosmologically, that's a near miss. Okay, and we didn't actually see this before it reached the sun. We saw it after it had passed the sun. So I don't know if that makes you lose sleep at night. You know, big rocks. Imagine something about 3 or 4 times the size of the Sky Dome falling out of the sky, hitting a city. Okay, it would make a dent. It would blow up that city. So that's a little bit unnerving. I like to look at the table that's on the space weather website. They talk about potentially hazardous asteroids. And there's another one that's coming in on the 17th, PHA. You sitting down? PHA 444584 will get very near Earth within 9 lunar distances. So that's much closer. And it's moving at about 15 kilometers per second. And it's over 300 meters in size. So that one's a big one. But we have a well-known orbit for that. It's going to miss us. Nothing to worry about here. But it's not like we can do anything about it. You know, we could ask Bruce Willis to go on a rocket ship, and he's maybe busy. We actually don't have a very good planetary defense system in place yet. There's lots of talk. The space agencies around the world are discussing this. There are conferences about this, but I don't know, if we see one coming in big, we're not going to be able to do a lot about it. That said, you know, the one that you may know of, the Chicxulub crater, that's in the Yucatan Peninsula, was made by a comet or asteroid that was 10 to 15 kilometers in size. Okay, so something that big coming towards us, we'll be able to see it, and that'll give you time to pack your bags. Asteroids that you can look at, that you can measure, that you can help refine the orbits on, are ones that block stars. Asteroid occultations are pretty common. I've noted 3 on our website that have ranks over 90%, that block stars that are magnitudes 11 to 12, and are going to block the starlight for 3 seconds or longer. So I've noted 3 of those. This is one of them that you can see, you can do from your backyard if you live in Toronto. That's flying right over Toronto. And that's at a decent time. It's around midnight between December 5 and December 6. So that's a good one to check out. See the webpage article for more. Of course, meteors are hitting the Earth all the time. I don't know if you know this or not, but the average value for the amount of material that hits the Earth every day is 100 to 200 tons. But most of these are small. They're the size of dust particles, and we see them as streaks across the sky. The Orionid meteors happened a short time ago. Anybody see any of the Orionids? Rhonda and I were in a dark sky location, and we counted around 20, which is on par. That's the blue hump here in this graph. So the one between October and November, that's the Orionids. The Leonids are coming up soon. Again, there's not going to be a moon around to see those. The Leonids are the little gray taupe hump here, this little short one between November and December. But that's about 15 per hour. The interesting thing about the Leonids, though, are they are the fastest moving meteors at 71 kilometers per second, and they often produce fireballs. And I don't know what it is, but this is one of these things that the media gets on every year. Oh, the Leonids are going to be the best meteor shower ever. They say that every year, and it's usually bleh. But you can see that when you look at this chart that we are in winter meteor season. But a lot of people don't consider that, or they know about the Perseids, of course, in August, but there's lots of meteor showers going on in this time of year through to January and February. And notice the red line there, that's the Geminids. And they produce 120 per hour. That's 2 a minute. So strap on your woolies and go outside on December 13th. Oh, that's a meeting night. But maybe around that, take a look at the Geminid meteors. Oh, was it that day before? Okay, good. Fun fact, the first photograph of a meteor was taken on November 26, 1885. Some constellations for your consideration. I've noted some constellations that are up high in the sky that hopefully we'll be able to see through cloud and so on. I have one constellation that's quite low in this presentation, so it's a challenge target for you. And then on the website article, I have one that's even lower in the sky. But we'll start with Camelopardalis, that's very high in the sky, which is mostly made up of faint dim stars. Hard to make out the stick figure of the giraffe in there, but it's very close. You can see to Ursa Minor and the Polaris star. So here's some of the objects that you might consider in this area. There's a tight double star, Struve 389. There's a big open cluster, Colander 464. I've noted in the many of these constellations ARP objects. This is a catalog by Halton ARP that are very faint, dim galaxies, and usually it's a galaxy or features a couple of galaxies that have been distorted or morphed in some way, because there's usually a bunch in the area and they're interacting gravitationally with one another. So if you see them, they're usually very interesting to look at. You will also notice that there's a comet in the area. C 2017-01 is exiting this constellation, moving towards Polaris. So that's a bunch of objects to try for. I forgot to mention at the beginning of all this that many of the objects that I'm talking about here, the planets and these deep sky objects, are targets on some of our certificate programs. So if you're going for your finest NGCs, the RASC finest NGCs, there's a few targets here. If you're going for your Herschel 400s, there's a few here. If you're just starting out with the Explore the Universe certificate, bunch of easy targets to get to. Here's Perseus. Lots of nice objects in this area. It's up high in the sky. Again, I've noted a number of objects here, including a Messier target, the variable star Algol. Up at the top of the Eiffel Tower is a nice double star, colorful double star there. There's another one of those ARPs. And then the finest NGC 1491, which you might get out the hydrogen filter for. If you have a hydrogen filter for your eyepiece or for your imaging rig, you might use that, and it's a very nice colorful object there. If you're looking at with just your eye, you'll see this faint dim fan-shaped object. There's Taurus. You can see the yellow line going through Taurus. Once again, that's the path of the planets, or the ecliptic. So that means the moon's going to wander through this scene at various times. Over the course of months or the year, you'll see planets travel through here. It's neat when the moon goes through here because there's a good chance that it's going to block a number of bright stars. So you'll get occultations or grazes of stars that are in this area. And of course, it has the two really bright clusters in here, perhaps the most famous of which is the Subaru or the Pleiades. Lots of interesting objects in here. And again, these are all documented on the webpage article. I've noted something here. You'll see the description microlens. So this is referring to a notification that was sent out by the American Association of Variable Star Observers a short time ago about a star that went from magnitude 14 up to magnitude 10. So it became much, much brighter, but it was determined that this is due to microlensing. And this was something that was predicted by Einstein like 100 years ago, where he talked about how light would be bent by extreme gravity. So the light pattern around some objects that are in this area are causing the star to appear to brighten. So it's an unusual event. I photographed it recently and it looks like it's dimming, but the AAVSO is asking that people continue to observe this and collect more data and do some reporting on that. There's the finest NGC 1514 that's in the area. This is my black and white image of it, but I'm looking forward to processing this in color because you can see that nebula around the star is a really deep blue color. So that'll be neat. Malcolm Park recently took a photograph of that, and you can see it in color. Here's Auriga. This is a fantastic constellation to look at with just binoculars. You can see the Milky Ways in the background. There's all kinds of open clusters and groupings of stars. You'll be able to see nebula with your binoculars if you're in a dark sky location. And of course, it's filled with a bunch of Messiers to look at as well, and another finest NGC in that area. Note the yellow line again. The planets are going to go close to that, so that might make for some interesting scenes. Here's Aries, kind of a bit of a weird constellation, that bent line stick figure. I don't know how you get a sheep or a ram out of that. I don't know, but well, it is what it is. So bunch of interesting objects in here. Note that the asteroid Iris, number 7, is in the area, moving to the southwest. The star that you can see, I've noted up near the top left here, HD 20367, is interesting. This is an exosolar system. So it has a exoplanet around it. The star is a G0 spectral class star, similar to ours. And the one known exoplanet is about the size of Jupiter. Now it's magnitude 6 or 7, that star. You'll need binoculars to pick it up. But it'll be interesting if you can see that star and you think about it, you go, there's a solar system there, and it's maybe like ours. So that's kind of cool. Here's your challenge object here, Fornax constellation, another silly stick figure constellation, 2 stars and a stick there. The furnace, I don't know how you get a furnace out of that, but so a bunch of interesting objects here. If you're looking for it, this is very low. The green line this time is the horizon. So it's just above the horizon, but you can see it fully clears the horizon. The other constellation I've noted on the webpage article is Columba. Did you know you could see Columba? All of Columba in southern Ontario. So some challenge low objects here, assuming you got perfectly clear sight lines to the south and clear skies, transparent skies. Hopefully you can spot these objects. Look for Orion. It's down and right of Orion. And you can see Eridanus weaving all around it to the left, and the bright star Acamar, the brightest star in Eridanus, may help get you in the right area. So that there's some challenge objects in there for sure. There's a bright planetary nebula, NGC 1360, in that location. So a bunch of deep sky objects for your consideration. Bit of an update on space flight, human space flight. Here, there's lots going on in Ottawa. If you're heading towards the nation's capital, there's the Canadian Space Summit, that's next week. And then in early December, there's the Dream Chaser event. The Boeing Dream Chaser craft successfully landed and didn't break its landing gear this time. The International Space Station, if you're looking for that, it will resume evening flyovers starting November 26th. So you'll be able to see that bright point of light silently moving across the sky, knowing there's some humans up there. The Orbital ATK company recently launched a resupply craft to space station. It's probably docking or has docked there now. And they named that space truck Gene Cernan, which I thought was apropos. That's the last astronaut that visited the moon. So Apollo 17, I don't know if you know this or not, but we haven't been there for 45 years. Humans haven't been in another world since October 13th, 1972. That was the space race, right? I read an interesting article on the BBC website a couple of weeks ago that was talking about the new space race, and it's between companies now. So it's kind of exciting what's going on. SpaceX and Orbital ATK and other companies, very, very active. SpaceX is tentatively launching on November 27th a resupply mission to the International Space Station. They've been really busy this year with almost a rocket launch every month, and they've been successfully recovering their stage 1 rockets. So they're driving down the costs of space flight. That's pretty interesting. The Australia country is celebrating their 50th anniversary this month. They were the 7th country to have a satellite in space. And they're launching a space agency. That was in the news a little while ago. So they're jumping on this new space race bandwagon as well. So lots going on there. I understand there's a secret mission by SpaceX launching tomorrow as well. I just saw that. Can't tell you about that though. This shot by Malcolm Park, I quite like. This is what you may see in a couple of days, assuming there are clear skies in the morning, where the moon and Venus and there's some other bright stars or planets up high there. Just to recap briefly, over the next couple of mornings, you have Venus and Jupiter in the morning sky, and the moon will be nearby. We have the Leonid meteor shower that might produce some fast fireballs and maybe will outburst. November 21st in the evening, the moon and Mercury and Saturn will be nearly in a straight line. I talked about those dates around the first quarter for Lunar X and the straight wall. And in December, starting on the 4th, we have the Geminid meteor shower, which peaks on the 13th. So try to see those. That's the best meteor shower of the year, in theory. And December 10, again, is a good time, a good evening to look at Uranus. So lots going on over the next few days. I just wanted to shout out to all the people that helped me build this presentation. I draw data from lots of different sources. I use lots of different software tools, so I just want to recognize all of them. Thank you. And again, everything that I've talked about is on the website. You can go to RASC-TO.ca. You'll find all the information there with all those other materials that I talked about. With your smartphone, you can scan that QR code if you want, and that'll take you straight to that article. There's probably no time for questions. Sure. Go ahead. One or two questions. Any questions? Any questions for me? So that's all for me. Thanks for your time. All right.
Thank you very much, Blake. Excellent presentation as usual. So clear. There were no questions. Yeah, the microphone is on. All right, so we'll move on to our solar eclipse roundup. And our first speaker is going to be Chris Joly. And let's use the microphone so that, come on up, so that we don't waste time hooking up everybody with this other microphone. All right.
Sounds like a plan. All right. Hi, everybody. Good evening. My name is Chris Joly. For those who don't know me, I'm an amateur astrophotographer, and I've been doing this since 2012. And I'm going to talk about my time when I've done my experience with the solar eclipse at the Ontario Science Center. And unlike last month's speakers, I did not see the full eclipse. I saw the partial eclipse. And I was very disappointed, but a week later I went to Bermuda, so it's a good trade-off. Yeah, so my morning started off waking up, showering, brushing my teeth, and getting ready to go. And the first thing I had to do is get some solar glasses for my brother, because he was hell-bent on seeing it with or without glasses. So I got him those glasses, and then I came straight to the Ontario Science Center and set up my telescope. And I'd like to thank Sean for helping me out with that, because I had the tripod, the mount, the OTA. I also had like the battery and so many other, and the solar filter. And I had to make multiple trips to actually get it from my car, which is parked in Lebanon, and bring it all the way to the area. And thank you very much. And that day it was a crowd. It wasn't like nightclubs are filled. Like nightclubs are not as filled as how many people there were at the Ontario Science Center that day. It was packed, and there was big lineups for the solar eclipse glasses that the Ontario Science Center was handing out, but also there was a lot of lineups for people to look through telescopes of the volunteers that were there, and it was very interesting. So when I got there, I set up my telescope up there, like get the tripod on, get the mount on, get the OTA, align it to the sun, and get ready. And by then, already a lineup had started to form. And I didn't realize I was going to be showing this to everyone, but I ended up doing it anyway. And a lineup came in, and I shared my telescope with everyone. and it was really fun. It was really interesting to see all the passion in everyone's eyes, and some people really were grateful that I was there because all the other telescopes were taking 3 hours to get to, and mine was taking only 30 minutes. So I was like, wow, how's that possible? But I guess there's that many people. So yeah, everyone was looking through it left and right. There were some good conversations that I had with some of the observers there, and it was good. By the time it got to mid eclipse, I had to kind of tell people, wait, I got to take my pictures. So I got I got my pictures, and then I continued, and by the time the moon was on its way out, people were starting to get antsy, and they were complaining like, when are we gonna see the moon? And 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 I was like, okay, you got to cut it down to 30 seconds per person, okay? And then to 20 seconds, and then to 10 seconds, and then no pictures with your cell phones. And then by the time it all ended, the eclipse was done, and whoever missed it, but no one really put up a fight or anything. So it was good. No one got hurt. But two things happened that were interesting, not related to the eclipse, but good things like two people. I was really parched at the time, and two different people got me bottles of water, and I was really grateful for that. And also, a gentleman came in with a camera like that, a microphone like this, and be like, "Are you a scientist?" And I was like, "No, I'm a business student." And 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 I just told them like how it is. Like this is a hobby of mine. I really enjoy this, and I definitely wanted to keep this going. And he's like, "Thank you very much." I don't know what he did with the footage. So now that everything is done, and once people were just going to look at the sun, and I lost the sun a few times, but by the time I lost the sun and I can't find it again, it's gone behind the clouds, and I started to pack up. And by the time I was getting ready to go home, one of the Ontario Science Center people, I believe her name was Rachel, right? I don't know, but they were looking for pictures for Global, and they got my pic, and I was able to give my pictures in, and I don't know if they were used, but they're there, and then I packed up and drove home. Like I was gonna give some people some rides, but there was not enough space in my car for everyone and my telescope, so it is what it is. And and then I went home and regaled to my dad. And that was pretty much my experience for that time. And overall, it's nothing like seeing a full eclipse. That was quite like watching YouTube videos of people enjoying it was great, but it wasn't the full eclipse. And also, it's watching a partial eclipse was fantastic, but it's nothing like a full eclipse. But this was good training for the next eclipse. Thank you.
Thank you so much, Chris. And I will call on Vikas, Nath, and family for their report on what they saw during the eclipse. Very good.
Hello, my name's Artash.
And my name's Arushi.
And we're going to present you about SolarX, which is about measuring data from the last 2017 eclipse using SolarX. So we had lots of questions about the eclipse. During the eclipse, will the temperature drop? Will it become more dark? And how much more dark? So to answer these questions, we created SolarX. Now, like all our projects, SolarX started with paper and pencil. We designed how exactly would we want SolarX to do, what are the sensors we would put in SolarX, and how exactly would it work. Then, as we knew we would have to carry SolarX around a lot to the places where we're going to see the eclipse, we went around the house to find a box or something that could contain all of the sensors that we had. So we ended up finding a lunch box that we would attach the sensors to. So then we added the sensors. There are lots of sensors: infrared sensors, visible light sensors, ultraviolet sensors, temperature sensors, and a solar panel so that we could actually see what's the difference in power as the eclipse happens. This is SolarX. So these are the sensors. And this is actually an SD card module, so that as the SolarX is on and measuring, it'll automatically store all the data inside the SD card. And also a time module here, so that it can also give a timestamp so we know when exactly the measurement was taken. So then, of course, we had to code all the sensors to the Arduino chip. So, and here is an example of the front of the code that we used. So after this, we had to test it to make sure no mistakes would happen during when we're actually measuring it for the solar eclipse. Then we found out that lots of people actually travel to see the solar eclipse, and we did some research and found out that Carbondale was the place where there would be the maximum amount of totality. So we decided to go to Carbondale. Now, Carbondale and Toronto are not very far from each other, only 1,300 kilometers approximately. But we decided to take a small detour, going 8,000 kilometers extra than we need to.
So we took a plane first, Toronto to Victoria. Then we took a boat, Victoria to Seattle. Then we took a train, Seattle to Sacramento. And then we took another train, Sacramento to Carbondale. When we arrived at Carbondale, it was the middle of the night. And we were very surprised next day to see lots of eclipse activities everywhere.
Then, to get to know more about what we were going to actually see, we attended seminars talking about the eclipse. And then we went to a stadium, the Saluki Stadium, and we saw lots of expositions from stalls from the NASA and stalls from other science companies. And after that, we visited the Southern Illinois University, where we met the dean of the university, and he was really interested to know about SolarX. And he asked us, what is the sampling rate of SolarX? And it actually turned out that he was also Canadian, from Calgary. So then, now the sampling rate of the SolarX is every second. You might wonder why it's every second and why so short amount of time. But in solar eclipses, things seem to change really rapidly. Like suddenly the darkness darkens and temperature drops. Then finally, and we also got baseline data so that we could be more precise. So the day when we would actually measure everything, we'll get a better idea of what are the measurements. So finally, the big day had arrived. We went to Attic Spark, and we set up all our instruments. Like we put SolarX in the shade because we don't want to measure the temperature of the direct sunlight because that'll make it imprecise and really high. So we put in the shade to get a better average reading. And yeah, so then we watched the solar eclipse. And at the end, we had actually got 22,000 lines of data, approximately, from each of the sensors, so around 150,000 data points. After this, we wanted to analyze our data to get a graph. So we plotted the data, and this is the graph of the light and the solar voltage output. So you can see that the light dropped around 35%, whereas the solar output actually dropped 95%. You can see they dropped at around the same time, at around 140 or 120 actually, and that is actually the moment of totality. The next graph that we made was plotting the infrared and the temperature. The temperature dropped 13%, and the infrared dropped by over 85%. And again, like the previous graphs, at 1320, it's the maximum, the least data, the measurement of data.
And then we decided to use the NASA Globe app, and we actually saw an organizer of that. It said that every 10 minutes you should measure the temperature, and every 20 minutes you should measure the cloud cover. And this is what we got. You can see it's dipping. Next. And when it was totality, it became very dark. The insects were chirping, birds going to their nest.
And this is a short video of showing like the instruments that we had put, including instruments that we used to measure the wind and picture of SolarX. Also a fast-forwarded video of the skies around the time of the eclipse. So this is where we had put the base. Here is the thermometer that she used to measure the temperature and to put on the globe app in the sheet. And here is SolarX that kept recording automatically the data.
So the balloon is
now
saying
here
that the
is
wind
you
direction
have
has
seen the
changed
balloons
from,
early in the
it's going from south to north. So the wind is roughly, it's southeast basically. It's a southeast wind right now.
So, yeah,
And the wind has slowed down.
Motion is tilting in to get the wind direction. This is a picture of the skies around the eclipse time. So it's not yet totality yet. You can see that there's a big cloud. And this is a picture I got from my camera of the eclipse with an Eclipse filter in front of my camera. And as I told you, the big cloud went in front of the sun, so we couldn't actually visually observe totality and diamond ring or Rayleigh speed, but we will be back because in 2024, Carbondale is actually the crossroads of the 2024 eclipse. Thanks. And we thank the Royal Astronomical Society of Canada for keeping us excited about space. And thank you, that's the end.
Any questions?
Yep.
What did you use to power your SolarX equipment? It wasn't just from the solar panel, right?
No, we are connected using this USB cable to a laptop, and we could actually also see from a serial monitor the data getting plotted. Yeah.
Sorry, I have a question. Back when you showed the graph of the, I think it was the infrared radiation, and yeah, that green spike at 12:45 or so, any idea what caused that?
Well, sometimes, like, we moved SolarX a bit,
Oh,
and like because of the wind, the tree, the shade of the tree above maybe moved, so some direct sunlight might have.
okay,
interfered.
thank you. Thank you. That was a real mystery. I couldn't figure it out.
Actually, it was a very much of a difficulty for us to keep moving because the shadows kept on moving.
Yes.
And we had to actually keep the SolarX in the shade. I mean, we tried our best to not to touch it, but sometimes the branches would move because of the wind. And actually, we had taken, it was her birthday in the train, but we used the balloon as a wind vane because we were trying to understand which direction the wind was going. So I actually had about 70 observations written, which we are hoping to publish eventually to understand fully how much data was collected. In fact, in Carbondale, they were also sent some of the sensors on the balloon up altitude. So we are planning to have a cross-linking of the data of ours from the ground level, as well as getting the vertical separation of the data. So we are hoping that, I mean, we were very much interested in the science of the solar eclipse. So we are thinking that eventually, more than the visual observation, we are able to understand that. And the idea is to get some kind of a heat equation of the Earth, basically, that in 3 or 4 minutes, if it can lose 5 degrees, how much, would be the factor of the equilibrium, basically. So we are hoping to continue this project.
When you said it was in the shade, were you just using the leaves on the trees to shade it? Did you have a screen?
No, we didn't use a screen. We just, because it was an open park, it was.
So if the leaves were moving or the branches were moving, then the amount of shade could
Yeah, it was a
change?
good enough tree, but the whole idea was that after some time, if it was a very big wind, then there might be some canopy, there must be some light filtering through the canopy of the tree. But for most of the percent, if you look at the graph, it's fairly stable, and the dip actually starts at 12:40 basically. That was the time when the totality was about 30%, I mean, because before that the impact wasn't too much, and then the dip really happened very smoothly in the other graph. We have 2 or 3 other graphs actually, we didn't want to put it up there, but we are hoping that in the paper we would be having, because we have a lot more data than we can handle actually, which is a good thing for us.
This is really impressive.
That's a lot of data.
And it costs around $80 for us to make this actually. So it's not a very expensive thing, and it's a very hardy one. We have used it to demonstration in lots of other places. Thank you.
So while you were collecting the data, how did you guys enjoy viewing the eclipse?
Well, we didn't actually have to operate the SolarX while we did it. So SolarX automatically stored everything in the SD card. But we were watching the eclipse the whole time otherwise. And yeah, it was really amazing how we saw the moon right in front of the sun. We got some good pictures. But we didn't, as I told you, we didn't see totality visually, but we could experience we could see all the birds flying home and the crickets chirping.
Thanks. Yeah, absolutely.
Our next speaker is Charlene Norgrove. Here she is.
Where's the other? Where's the other? Charlie? You want to use the other? I put it on.
No, I'll try this.
Okay.
I'm gonna go. I can use this stuff.
Do you have some slides?
Yeah, I need that. Thank you.
Charlie? Charlie? Here, up here. The microphone up here.
Yeah.
Okay, yeah.
I'll try to remember that. Yeah. Okay, my family and I went to Idaho for this eclipse. I treated them. Thank you. My family and I went to Idaho for this eclipse. I treated them to this. I flew. This is going to be difficult. I flew to Boise, Idaho, and they drove from California and Nevada. And then we drove 2.5 hours north to Cascade, which was on a lake. I have 5 minutes, so this is going to go fast. I rented a chalet, really beautiful chalet, wraparound porch, 2 fireplaces, hot tub, and we were there for 4 days before the eclipse. So we had all kinds of time to do hiking, biking, fishing, whitewater rafting, and jet boating. So this was the whole experience. Day before, we cut up a pillowcase. We made pinhole cameras. We tried those graders. They didn't work worth a darn. But it didn't matter. That's what you got from the trees. And on the first slide was just through the trees during the eclipse. Okay, so this is the day before the eclipse. This is the view from the chalet out over the lake to the east. Okay, so the clouds were coming around. I was starting to get worried. We took a drive. We went hiking that day. It was lovely. But on the way home, this is what we got. The clouds started coming in, had lots of high clouds like this covering the whole sky. Not all of them are as picturesque as this. But we were really lucky. The day of, look at that sky. Absolutely gorgeous. You know, so, and we just set up right out on the driveway of the chalet. We had an absolutely perfect view. Okay, this is the day after. From the plane leaving Boise, that's Boise, the drive from Cascade Lake down to Boise, the sky was completely gray with wildfire smoke. So we were out there when the wildfires were active. So we were extremely lucky. Okay, but what I want to talk about here is I'm going to follow up on the Nath family's measurements here a bit. And I think that we should probably send them over here to the University of Madrid because they probably did it a whole lot cheaper than they did. I saw online a professor from UBC, posted a diagram online, which is the next slide. And I'll show you. And I thought, okay, where did he get this? Because it's from Cascade, Idaho, this graph, which is where we were. So I thought, what happened here? Well, the University in Madrid had an expedition to Cascade Lake. And they used photometers built for NASA's Transiting Exoplanet Survey satellite to measure things. So what you've got here is the temperature sensor is a green cylinder. This is the test B photometer. These colors are meaningful. I'll show you next time. This is the test W photometer with a solar filter on, a camera, and a light meter. The solar filter is needed to record the brightness during partiality because the test photometers are designed for night sky brightness. So here's what we got. This was the graph. Just about like what they did, what you did for $80, right? Pretty good. So this, I was only interested in the air temperature and the brightness of the sky, which was extremely noticeable. Now we were at about 6,000 feet high and forested lake, you know, so the red line is the brightness of the sky. You can see it went from, where'd it go? It darkened by about 9 magnitudes. It went from about 6 down to about 13. 9 to about 13. That's the data from the filtered photometer is in red, and the unfiltered photometer is in green, and recorded that drop. The temperature variation is in blue, and it was recorded with another sensor that's inside the test W, and it dropped by 10 C. At where we were, the temperature at 1 o'clock was 27 C. It dropped to 17 C at 1:30, which is going from 80 F to about 62 F. It was very noticeable. Let's see, what else can I say about this? Oh, the delay. There was a noticeable delay in the brightness, the temperature, and the brightness dropped, and the temperature dropped later. That's a real measurement. They measured that difference in the bottom point on that with those expensive instruments. Okay. The other thing, one more thing to talk about, and I'm just about through, that nobody's talked about is this.
Yeah.
Okay, about 20 minutes before totality, until about 20 minutes after totality, we got eaten alive. We were right next to the woods, you know, and all of a sudden my son's coming over and he's slapping me on the back. I said, "What are you doing?" He said, "You've got mosquitoes all over your back." You know, and not before, not a mosquito inside before, not afterwards, just during. So, okay, I got one photo of the eclipse because I was busy with my family. But I'm pleased with it. It's just an amateur photo, but I like it. So, and I didn't do it. This is the color of the sky. I didn't do anything to this photo except try to clear up the eclipse just a little bit. But I was happy because I did manage to get Regulus in there. So I'm happy with my amateur photographer. It was a wonderful occasion for the whole family, and we did get to see totality in between those two cloudy, smoky days. So thank you very much.
Let's see. I can't see the crowd, the audience, because of the bright lights. Any questions for Charlene? No questions. Okay. In that case, we will. Yeah.
I have to think about it for about a second.
All right. So let's move on to Dan Paul. Come on down. So Dan, we're actually making pretty good time. If you want to go a little bit longer, you're good.
Okay, awesome. And okay. For my,
You have slides as well?
yeah. Okay, thanks. And then do I use this guy here? Okay, I'm sure it'll work out. I didn't. Hopefully this. Okay, sorry, it fell off. So give me just a second here. This is going to eat into my a lot of time. Now I didn't talk time this out, but maybe when I get down to my last 90 seconds or something, if you could just like wave at me or something like that.
We're making good time.
Okay. All right, hopefully this will stay on. I know, my cell phone takes up too much room. How about like that? Okay. Can you guys hear me? Is this okay?
Yes.
All right. Yeah, well, these have been terrific presentations. I doubt that I can top them in any way, so I won't try. I will just say what I've got. And I also don't have like sort of data. We had like some hardcore science here today, which is awesome. I just have like some pictures and some anecdotes. Okay, let's see. And actually, I've got my little pocket guy. Oh, yeah, okay, it's hard to see. All right, so why this place in Oregon? We actually chose a place called Detroit Lake. And here it is. It's an hour's drive east of Salem, right? So this is Salem. This is Portland up here. Why this location? So I went with my friend Chris, and he and I were both sort of into photography. I'm more the astronomy guy, but after today, he's into astronomy. I'm actually kind of privileged because this was my 5th total solar eclipse. It was the first one for my friend. So why this location? Of course, everybody knows the weather prospects were supposed to be better as you go west of the Mississippi. I think that actually was borne out as it happened. Why near a lake? Well, as a photographer, I like having something pretty in the foreground of my photos, so a lake seemed like a good idea. But there's one other reason too, which I was very concerned about crowds. There are all these articles in the papers, and I guess actually I wrote some of those articles. But anyway, there were a lot of stories saying, "Oh my God, it's going to be crowded. It's Eclipse Mageddon. Everybody's going to be on the interstate, and then everybody's going to be at your observing site, and it's going to be chaos." But I thought, well, if you're by the side of a lake, no one will be in front of you. I mean, unless they're in like a boat or something, and that's a smaller number of people. That was what was going on in my head. Okay. So on the way there, so this is now the day before the eclipse. We're driving south from Portland to Salem. They're getting set up for viewing at Willamette University. Lovely poster. I didn't get a physical copy of it, but I stole their JPEG. I think this is lovely, but of course I wasn't. By the time this happened, I was already at Detroit Lake. But it's kind of cute. We ran into Jay Paskoff. Some of you, I'm sure, know Jay, or at least know of him. He's seen, rounding off here, a zillion total solar eclipses. I've forgotten the number, but it's huge. I believe he is the world record holder. Of course, these records are a little fuzzy, and you never know if people are lying or not, but I don't think he really has seen a lot. I profiled him for Quanta magazine. The article ran a week or so before the eclipse, and whatever that number is, it's in the article, but I forget. But it's way over 30. And of course, if you count partials and annulars, it's much more. We also talked to some of his students, and God knows how much gear these guys brought, but it's a lot. So now it's the afternoon or the evening of Sunday, so that's the day before the eclipse. And the question is, where is everybody? All these articles that were saying that it was going to be mega crowded don't seem to have been borne out. Now, I'm sure they were borne out east of the Mississippi in various locations, but it really wasn't an issue on Route 22 heading east from Salem towards Detroit Lake. Here we are the evening of August 20th. That's my friend Chris. So far, crowd control not really an issue at this stage. So things are going well. So yeah, we stayed at a motel up the road, which we booked about 1.5 years in advance. That was a smart thing to do. I mean, finding accommodations was or would have been tricky. But just finding a place to like put a tripod and have room to go like this, that actually wasn't so bad. So the motel is up here at the north end of the lake in the town, very, very small little town. As we were scoping it out the day before, and of course we had looked at the Google Maps and so on, but there's a state recreation area here, and as you know, the azimuth and the altitude of the sun, right? So at eclipse time it was going to be in the southeast and 40 degrees high in the sky or whatever, so you want to have a clear view in that direction. So we figured, all right, this area will be pretty good. We were not at all sure we would be able to park there. It's a campground, and it's set up for people who stay overnight, and it wasn't at all clear that you could just show up and park your car if you weren't one of the campers. So we just this was sort of how we calculated. We drove 1/3 of the way and said, well, we'll just park, just leave the car on the side of the road, as a few other people had done. Later, there were warnings that, they have this alert system so that your phone goes ping and says what is going to kill you next, right? So the phones were going ping and saying, don't park by the side of the highway because your car could start a fire or something like that. But it was too late. We had already done it. By the time our phones started pinging, we were already down here. But anyway, we parked, we walked. I know the scale is a little hard to tell, but it's more than a kilometer. It's, let's say, on the order of 1 mile, with, of course, all our stupid gear and our backpacks and stuff like that. But nonetheless, I think we did the right thing. It's better than driving here and finding that you can't park and then having to go back there and, wasting extra time. So, as I say, we walk to the Detroit Lake State Recreation Area, where we find sort of an official, looking figure. This isn't actually him. This is a representation of a generic figure of this type, who had not been there the day before. When we were scoping it out the day before, there was a friendlier fellow just at the booth giving information about, if you wanted to stay for the campsite, which I'm sure the campsite must have been filled up. But at any rate, so the previous day we sort of scoped it out. But the bottom line is it wasn't really set up for just day use. I mean, there are parks that are for that, but this was an overnight campsite. And I think they were worried about just every idiot from the whole county coming down and deciding they were going to spend the afternoon at this state recreation site. But it was still quite early in the morning, and he was pretty sympathetic to us, and also we were on foot. So we just kind of said, like, well, we walked all the way from town, which is kind of true, right? We walked all the way from town. Can we please just hang out here for a little bit? And he said, all right, come on in. Now, I don't know what he said to the next people after us. And I guess our backup plan would have been to go all the way, I don't know, wherever, further to the south end of the lake or back to the north end of the lake. The entire lake was in the path of totality, but nonetheless, we wanted this sort of nice spot. Now, this is Eclipse morning. There are some issues, and one of them is fairly obvious, and it was actually hinted at or said in the previous talk, which is the forest fires. So everybody knows that forest fires are a real possibility in the western United States. I knew, I guess, but I just, much like, when your doctor talks to you about like some body part that you don't think of, like, I don't know, your prostate or some other thing, you think, well, whatever. Like the doctor's just gibbering on and on. It's not going to affect me. So I thought these forest fires aren't going to affect me, right? And really, we didn't notice anything weird the day before. We didn't notice anything while we were in Salem or in Portland. But now there was definitely a haze. I mean, you can see it in this picture, right? It's kind of a smoky haze, and you could smell it too. I mean, it wasn't overwhelming, but it was bad enough that if you didn't have a really good reason to be there, like a total solar eclipse, you probably would just leave and go somewhere else. It was smoky enough that you definitely noticed it. We found out later where the fires were. We actually know the name of it. This one was called the French Fire. I don't know what it's named after, but now we know who to be angry at. But it was quite local. We were told that this fire was about 5 or 6 miles away. So the fire was quite nearby. All right, so I won't bore you with the details of what I took. The closest thing I had to a telescope was just a camera with a DSLR with a pretty good telephoto lens and a bunch of other stuff. But in summary, don't ever try to take all that junk with you to a solar eclipse. I really don't recommend it. And for the main reason being that the more time you spend fiddling with your equipment, the less time you'll spend looking up at the eclipse, which is really what you should be doing. And now, again, I've been to some solar eclipses previously, so I guess it's less tragic in my case than it would be for someone seeing it for the first time. But all those articles that you read in Astronomy and Sky and Telescope and Sky News that says, don't take photos, look up at the thing, that was all true. Like, just don't look down at your equipment. It's a terrible waste of time. Okay, so the partial phases went quite well. Oh, I guess an exception to that, what I just said is, as the kids did with the SolarX, if you can automate it, if you can automate everything, okay, that's cool. And if I can, sort of figure out how to do that next time or something, I think that's the way to go. Or just set your cameras in video mode or whatever. But if it requires your attention, that's a bad thing. So things went pretty well during the partial phases. I guess this is one of my better photos. Just again, DSLR telephoto lens. I can do some frequently asked questions. Dan, the focus is pretty sharp. I assume your telephoto lens maintained its focus over the entire duration of the eclipse. No, not really. Things kind of shifted a little, whatever. But this is not bad. Now we're well into the partial phases. The so-called crowds have built up. I mean, there are a lot of people, but they're spread out. They're spread out in a pretty reasonable way. It's just not like, so in our sort of immediate area, I mean, there would have been 30 or 40 meters between us and the next humans, but there were, I mean, they come clustered, in families or whatever. But anyway, there was lots of room for everyone. You do get a sense of this haze never really left. This kind of smoky haze was there the entire time, but it was not opaque. I mean, we could see through it, but it's just like looking through a thin or medium thin haze. So, and you see it again here. So here we are very, very close to totality. Using one of my 7 cameras, I took this picture. I don't know if it was 7, 5, whatever it was, some ridiculous number. And this is actually not bad. I mean, this is a pretty good recreation of what it actually looked like, or what I imagine it probably looked like if I had looked up at it. I'm exaggerating a little bit, but not. I know it's funny because it's true. Yeah. And here's totality. And that's not bad for a point-and-shoot camera. I mean, it's not going to win any prizes, but it's thanks. Yeah, so that's not so bad. So let's see. I forgot what else I've got here, but I've just got 1 or 2 pictures left. Okay, so I glued this together, and I probably included the wrong one. So this is, I guess, the bad one where I forgot to blur the boundaries between the each part of the montage, so I think somewhere I have a better version of this. But at any rate, it's not bad. These are just assembled in Photoshop, all pictures taken with the telephoto zoom lens on my Pentax APS-C sensor DSLR on a sturdy tripod. The pictures are okay. It just took me too long to make sure that they were occurring correctly. This is one of the things that ought to have been automated. And what else? And you can kind of tell, right? There is something a little funny here, right? So these colors, in Photoshop, I did not change the colors in any way. So you can see there is something a little funny going on here. And I would say that this weird reddish coloring has something to do with all the haze, the smoke and the haze from the forest fires. Well, again, mercifully, these are shrunk down to fit them on the montage. So you can't really see how bad the focus isn't horrible, but the focus did gradually get worse as the event went on. But it's not bad. And this is, I mean, this is as close as I've got to having like the really good diamond ring picture that everyone wishes they had. But whatever, it's something. It's okay. And again, in a montage, it's not too bad. This is a little while after totality has ended, and you can see the haze is sort of even getting thicker. I don't remember exactly what time in the early afternoon this was, but let's say it's an hour. Maybe this is an hour and a half after totality has ended. I'm not sure. But it gives you an idea of just how thick. I grew up in Nova Scotia, so we're used to fog. And it's possible that some of this is fog. I don't know. I'm not an expert on these things. But a chunk of it, I suspect, or I'm actually pretty sure, is also forest fire related. There's probably a combination of things going on here. We drove east. I figured we were in that part of the United States. We just went on a long drive over a couple of days after that and visited Grand Teton National Park and also Yellowstone National Park. And I hadn't been to either of these parks, so that was my first time. Obligatory Old Faithful photo, and saw a whole bunch of bison. Felt a little bit guilty about the bison burgers that I've had over the years, but having said that, they were pretty delicious. But it's actually, you can't tell in this photo, but these national parks are very, very popular, and it's almost a bit disconcerting to see the crowds of people. I mean, yes, there's a herd of bison, and I don't know if we outnumbered the bison or not, but I mean, you do get this feeling that we're maybe intruding on their territory. Did a bit of nighttime star trail astrophotography. I do like to do this sort of thing. I haven't figured out how to do it with a digital camera yet, but I do know how to do it with a film camera, so I just did it the old school way. I like to pretend it's 1983 or something, and that's roughly the epoch that my SLR is from, and did some time exposures. Took a whole bunch, most of which are not worth showing anybody, but I sort of got two two reasonably good ones. They don't. The film that I used to really like for this was Provia 400. They no longer manufacture it, so the closest thing that you can get is Provia 100, and then you take it downtown and tell them to push it 2 stops, and you pay extra for that. And I mean, the cost of I won't go on and on about it, but the cost of this hobby has gone up kind of a lot recently. Yep, that's it. Thanks very much. If anybody has any questions, I'm happy to.
Questions for Dan? No questions.
It was so clear there. All the questions have been answered.
First, sorry, one.
Oh, yeah.
More a comment, Dan.
Okay.
Your concern about crowds was thoroughly justified. We were just south of Salem, and because of the crowd warnings, we went to our site just several hours beforehand. So we arrived there in the dark with the whole family, with little kids and everybody else, and it was okay coming down. It turned out that we were living or staying in Portland. It took us an hour to get there, just like Google Maps said it would. Going home, however, after the eclipse, and this is well after the eclipse, it took us 6 hours to get a 1 hour drive to get back, because everybody's back on the interstate.
Yeah.
To get back at the same time.
Yeah.
I've heard stories of similar things, that going to the eclipse was relatively good. Coming back from the eclipse was a nightmare.
Because everybody wanted to get home by dinner time.
Right, and people knew enough to get there early, but people still wanted to bail out. And I had read, there are all these maps about the so-called choke points, right? People had predicted, it's where the interstates, where the north-south interstates, of which there only are a few, intersect with the path of totality. That's where the crowds are going to be. Apparently this was correct. And we saw on the news, so we stayed in Detroit Lake, and luckily we were there 2 nights, so after the eclipse, we didn't have to drive anywhere. We just had to sit down and watch TV. So we saw pictures of people trying to drive home to Portland, from Salem to Portland, and that apparently, as you're suggesting, was a very, very long wait for those people. As for the folks I don't know how crowded it exactly was in Salem, but if you say you were a little bit south of Salem, right? So you were probably very close to the center line.
We
right?
were the closest place. We looked up all the vineyards that were hosting this.
Priorities.
And we found the one closest to the center line, and they still had room, and so we booked into that. But that also limited the crowd, because they would only take 500 people under this whole vineyard.
Yeah.
So it was perfect for us. But the smoke was all the way around, and it sort of enhanced the 360-degree sunset. But we didn't smell it. We were up above it more, I think.
Oh, okay.
Than you
Yeah.
were,
I mean, so from seeing what people posted from Salem, I think they had very, very good conditions, as far as I know. But yeah, I don't know if I had sort of especially bad luck with forest fires, but I mean, I can't be the only one. Again, there were forest fires in Idaho, there were forest fires in a lot of different places. I think the people in Grand Teton in Wyoming had really, really good views, but yeah, it was hard to predict exactly the best place to go.
Thank you very much, Dan, for sharing your experience and for a very entertaining presentation. Okay, so now we'll move on to our final speaker, Ron McNaughton, and they'll tell us about from Messiers to spiral arms. And
Can I use this?
yeah, absolutely.
So this goes.
That one you can clip on there, yeah. And I'll start your presentation in the meantime.
And this goes.
That one there.
Can people hear me?
They won't hear. I will.
All right.
No, don't just say okay, because I had to. It's part of a. There's a short video in here, and the video has to be part of a folder that is loaded together. All right, so let's see if I get the right back. Years ago at a Star Party, I had chatted with the cook for a while, and when he finished his duties, I had my telescope set up, and he came over and we were chatting, and I asked him if he wanted to look at something, so I pointed my 4-inch telescope. Let's see if I get this working right. Did I press the right button? At that. And we all know what that is. Most of the time, I find when people look through my scope, they look at it a little bit, and there's usually a comment about, wow, that's beautiful. And there are other people in line, so they don't stay too long. He looked for a good solid 2 or 3 minutes and said nothing. And then I said, after that, you know what do you see? And this guy might have been just a cook, whatever that means. But he had staggeringly, I'm trying to get the laser thing, he had staggeringly accurate description, he said, and this is a 4-inch telescope, remember? He said, well, it looks like it's flat, but it's tilted to one side. It's brighter in the center, and it gets less and less bright as you go outside. And he talked about something that there were dark circles in it. I mean, what a description. And he wasn't even an astronomer. He was just hired as a cook. And then I said, what do you think it would look like for somebody maybe halfway out inside here? What would the sky look like? And he said, I really don't know. And then I said, look up. And he went, wow. Because it's exactly our situation inside the Milky Way. And we have these, oops, wrong way. Can I go back? Yes. Sorry, we have this pattern here of, and of course this is the summer Milky Way, this is Altair, etc. So that's it. We can actually figure out a lot of the patterns of our galaxy by looking at the patterns of the Milky Way and specifically the Messier objects. So, too far. All right. So I'm going to show you a number of maps showing you all sky. So this is zero right ascension, which means that the sun is in front of these stars on the spring equinox. And in the spring, we have a nice view of Leo and that sort of constellation, and of course the Virgo cluster. In the summer, the sun goes further north, and it's in front of the stars of Gemini, my zodiac constellations. You know everything about me from that. And of course, the Great Orion. And what can we see at night in the summer but Sagittarius and Ophiuchus and etc. Then you go one more season later, the fall equinox, it's here. And in the fall equinox, you have the great view of Andromeda and M31. This was August or September, that star party. And of course, in the winter equinox, these are all next to the sun, and we have a great view of Orion and the wonderful gems there. This line that I put on, and is not that accurate, is the rough brightest spot of the Milky Way. So the Milky Way goes up through Sagittarius, Aquila, up Cassiopeia, down through my zodiac constellation, and down into the south. So what do you think the concentration, the pattern, the next picture shows the Messiers. Any prediction on the pattern of the Messiers? This is all the Messiers. I found a program. By the way, I made this talk up 15 years ago, and I couldn't find the program. But these are all the Messiers. Now, Chris and Charlene, is the reason there are no Messiers down here because there's nothing in the southern sky worth looking at? Obviously, he lived in Paris and couldn't see the south. But there are more patterns than that. You notice that there's quite a bunch here around Sagittarius, but there's also a bunch around Orion. And that tells us something about the strategy, the pattern of the galaxy. Now, there's a bunch here, and this is the Virgo galaxy cluster, and I'm not going to talk anything about external galaxies because they don't tell us much directly about the Milky Way. I'm going to go now type of object. So I'm starting with globulars. And globulars are some of the oldest things in the universe. They have, let me go back, wrong button, this one. They have maybe 1 million stars. There's very little dust. They don't flatten because the dust, when dust goes down and dust goes up, it cancels out. But this has no dust. They're very old, and they're all over the place. So, predictions. Where do we have most of our globulars, or are they? Random. Comments?
Near the core of our galaxy.
So, so most of the globulars are Sagittarius region. There are a few that are on the other side of the galaxy, but most are near the core. And Harlow Shapley, I think that's his name, he measured the distance of globulars in the, 1910, something like that. They looked at variable stars, and from the period of variable stars, they can work out the intrinsic brightness of those particular stars. And he got distances to galaxy or to the globular clusters, and he found they cluster in a spot about here that turns out to be something like 27,000 light years away. So that data showed that we're not in the center of the galaxy. The center of the galaxy is over here, and it's also towards Sagittarius. Why isn't it moving on? It turns out radio telescopes found a source of radio waves, Sagittarius A star, for some reason it's called that, that's there. And when they use infrared telescopes, now, it did work before. Let me go back. Press what? Okay. It did when I tried it out. This was taken in infrared, which penetrates through all the dust that's near the center of our galaxy. And these stars go around this spot, and then it zooms in, and there's one star, S2, that goes particularly close to it. And this is a summary. Didn't I say I gave this talk a long time ago? 2002 is the latest data. I'm sure they've got another orbit since then. And I actually gave this to my grade 12 students because if there's a moon found around an asteroid, they can take the average distance of the moon away from the asteroid and the period of the time it takes to go around, and they can get a very accurate measurement of the mass. And when you do that here, as my students were able to do with a little bit of help from me, they find that there's something in the center of the galaxy that's about 4 million solar masses. And of course, that's the black hole that's the center of the galaxy. I read somewhere, but I haven't confirmed it, that there are 2 black holes in the center of M31. So, but that was a while ago. All right. We also can see something else by just looking at this, and that is the Milky Way is wider in the Sagittarius region, and it gets narrower as it goes further up. So just from our eyes, plus a little bit of measurement, we get a model of the galaxy that it's wider in the center. We're something like halfway out, although I'll get to that in a sec. And you have a bulge here, and it's mostly flat, just like M31. This was the size of the galaxy then, but it turns out the latest value is closer to 180,000 rather than 100,000 light years. But I haven't, other than the one graph where I added the Milky Way, I haven't changed any of the graphics here. Okay, now I'm going to look at diffuse nebula, such as, of course, this is the Orion Nebula. And these are star-forming regions, so it contains all sorts of dust that has collected in one area. Gravity's pulling it together. This is a not very good photo of the triangulum, of the trapezium in the Orion Nebula. And this is a very good Hubble photo showing some of these, and these are stars that are forming right now. And it's kind of amazing to see that. Okay, so I have to now use this. All right, what's the distribution of the diffuse nebulae going to be around the galaxy, around the Milky Way? Any thoughts?
Right on the Milky Way.
Right on the Milky Way? Well, we'll see. I guess I have to press this button. Now, there are a few interesting things about it. There's a clump of them around Sagittarius. There's a clump of them around Cygnus. And there's a bigger clump around Orion. And there's a clump down here. And I've never seen those things, so I can't comment much. But it's not just that these are on the Milky Way, but they're also concentrated in certain areas of the Milky Way. And something I find amazing is the constellation Aquila, right in the middle of the core of the Milky Way, doesn't have a single Messier in it. And it only has a few objects. And I'm going to get to the reason for it in a bit. Nope, I have to use this. Now I'm going to look at open clusters. Now, basically, if we waited a few 100 million years from the picture of the Orion Nebula, it would look like this. Forming stars, slowly drift apart, and this is Subaru or the Pleiades. The closest cluster I've heard is, believe it or not, the Big Dipper. Because according to the data I got then, these stars, not counting Alkaid and Dubné, but all these are almost the same distance apart away, and they're all moving, although that figure was different when I researched it, but I didn't change it. And that's probably an open cluster that formed a long time ago. So, what's our pattern going to be for open clusters? Thoughts? Remember, they're places that used to be star-forming regions? They are mostly even, but they are on the Milky Way, although they seem to vary from the Milky Way more in the Orion area. And interestingly, there are more of them outside than there are, like this is the galaxy towards the center of the galaxy, and this is away from the galaxy. Last type of object I'm going to talk about is planetary nebula, which is sun-like stars at the end of life, and supernova remnants. I'm leaving the galaxies that were part of Messier's list for later. They both produce dust that spreads into space, that gets into new stars and new solar systems that turn to make our planet something other than something made of hydrogen and helium and a little bit of lithium. So this process is important for stellar evolution. Predictions on the planetary nebulas.
Random.
Wow. Smart people. They are much less clustered on the Milky Way than the other types of objects, though the dumbbell is bang on the middle. But they're more random, and I figure that might be because the planetaries can't be very far away. They don't last long, and they're not very intrinsically bright, so they have to be relatively close, but I didn't get to research it. Any predictions for supernovas?
In our galaxy or in the whole sky?
Oh, in our galaxy, yes. Just Milky Way supernovas.
There's been what?
Pardon me?
In the last 500 years, there's been one?
I have one that goes to, I think it's 160 AD, something like that. I can't remember the number. Any predictions?
Are you talking about the remnants that we see also?
Oh, yes, that were supernovas, and many of these were observed by Chinese astronomers, and there was a really major supernova, and there isn't a word written in Europe about it. And this was really bright. That just says something about the mindset of Europe. They're pretty much right on the line of the Milky Way, with the exception of a couple here. Is that 185? Now, looking up this, the value was 1680, and I put a question mark. I didn't change the number, but if someone's looking for details, that is incorrect. So these seem to be right on the Milky Way, but maybe they're relatively recent stars that were, like Jimi Hendrix, live a rapid life, shall we say. And so they would form right on the Milky Way, and they haven't had time to move away from it. Who knows? So, we look at distant galaxies, and of course we see spiral arms. So, what causes the spiral arms? Well, just a minute. All right, I messed up the order here. I'm going to go, wait a minute. Have I lost something? I've messed up the order. Okay, there's spiral arms. I'll explain later how spiral arms get started, at least one theory. I do want to say one thing about spiral arms, though, is in this one, we're here, and there's a spiral arm outside of us that has the Orion Nebula and the many objects for Orion. Remember there was quite a bunch up of objects around Orion? And this one has a whole bunch of objects pointing towards us, towards the center of the Milky Way. But you notice that I said Aquila didn't have any Messiers in it? And Aquila is in this distance between the spiral arms, and maybe that's why, or maybe it's just a lot of dust. I don't know. But we can see evidence of the spiral arms. And also, looking opposite Aquila, out here, there were relatively few objects here as well. So the fact that even on the Milky Way, it's not evenly spaced is reflected in our pattern. So we're here. We've got the Orion arm outside us with M42 and a whole bunch of other things. And inside, towards the center of the galaxy, we've got Trifid and Lagoon and a whole bunch of summertime objects we see here. Now they feel it's more a barred spiral than is shown here, but this goes back 15 years. This is the explanation for spiral arms. The theory is that the stars are moving a little faster than the spiral arms. And just like when you're driving along, sometimes you get stuck in a slight slowdown and it takes a while to get through, and then you can go back to your normal speed, depending on the highway, of course. And actually, there's a name, they're called kinematic waves, and I've actually seen papers by traffic engineers about them. So the individual cars move through the traffic jam, and in the density wave theory, you've got incoming clouds and stars. They get squeezed when they hit the spiral arm. Stars form. Some of them don't last long. Some of them go through, and that's the theory for there. But what about speed? Anybody notice something about the speed of the different planets? The third rock from the sun goes about 30 kilometers a second. They're 9 dots. The further out, it's slower, but there's also 9 dots. Because I made it a while ago. Now, you would think in a galaxy that most of the mass is centered here, and as you go further out, the stars would slow down. And they can measure the speed of the stars because if the sun is here, this is a picture of another galaxy. Probably a lot of you know the name. I don't know, is it 101? Anyway, using Doppler shift, you can measure the speed of the stars here and the speed of the stars here towards us, and they can figure out the relative speed. And they find that unexpectedly, the speed does not follow the Kepler orbit that our planets do, but it sort of wobbles. And of course, that's evidence for dark matter. And here's our the barred spiral to show the later theory. Okay, here's the Messiers. Notice that in the spring equinox, the sun is somewhere around here, and you can see most of the Messiers in a marathon. And that's why this is the only time you can run a Messier marathon. I guess you could try it in the fall equinox, but I think the Virgo cluster would be brutal. I want to talk about a galaxy up here. Yeah, right there. That's M51, or the Whirlpool Galaxy. Now, this is the Milky Way. So this is looking straight below the Milky Way, and the Whirlpool Galaxy is looking straight up. Now, what I'm going to do is, this is a photo of M51, there's a second galaxy. And it was, Hubble published this, and they allowed you to zoom in. So I'm going to zoom into this area because the sun's position is analogous to somewhere here, between two spiral arms. So I zoom in more. See those two? So I zoom in more, and I zoom in more, and one of these stars could be sun-sized. I don't know for sure. And if there was somebody living there, looking up, they would see a galaxy in the sky that is also face-on, we call the Milky Way. And who knows if they wonder if their galaxy has the spiral pattern that this Milky Way does. And also, maybe they wondered if there's somebody at the other galaxy looking at them. Thank you very much.
Any questions for Rod?
It's kind of late in the evening. I think people want to go to the bar.
All right.
But if there are any questions, I'd be happy to answer them in the bar. I need a bribe, though, to do that. Okay, I guess I'd better take this. All right.
All right. Thank you very much, Ron. Wonderful presentation. All right, so that concludes our speakers for tonight. We'll wrap things up with our president, Ralph Chu, who will take care of the announcements for tonight. And I see that he has some calendars as well. I'll bring up your presentation. You can use that.
Okay, well, good evening, everyone. And just a reminder, I do have the 2018 calendar here tonight. So there's a box of 60 there. The 5 are already spoken for, but 55 up for grabs. So $20 each if you want to get those. Okay, so for the announcements tonight, the next meeting is going to be, okay, is this thing on? Okay.
Use arrow right.
Yeah, okay. Our next meeting is on 2 weeks from tonight, it's 29th. We'll have our speaker, Rachel Ward-Maxwell. Many of you have seen her over the last year opening up and greeting us here. And she'll be talking about what's up astronomically speaking at the Science Center. And then immediately after that, we'll have the annual meeting of the center. 2 weeks after that will be the last meeting for the year, which is Recreational Astronomy Night. Have Ed Trey's doing the sky this month, Scott Masterton reporting on his trip to Nebraska to observe the solar eclipse, and then a last presentation by John Bodanowicz on his observation of the solar eclipse. And I think we still have one open slot, so if anybody's interested in doing a presentation, please contact Paul about that. As far as the annual meeting is concerned, you've all received by email or snail mail a notice of the meeting, which will be held after Rachel finishes her talk. And the agenda is here. We've got the usual annual reports, then the election of the council for 2017-2018, the election of the auditor, and also we have some proposed bylaw amendments that we are presenting for approval, and those are posted on the website, and please take a look at them, and we'll be voting on those at the meeting. Okay, at the moment, the names in red are the candidates who have been proposed on the official slate for election at the annual meeting, and this evening is basically the deadline for any alternate nominations that have to be turned into Tom Luton, the secretary, if anybody wishes to contest any of these seats. And if that happens, then we will have an election. If there are no alternate nominations, then the people whose names are in red will be declared elected by acclamation. Okay, some other things to note of. This was done before the weather went south on us. And so in addition to solar observing on December the 2nd, we also have a session that's tentatively scheduled for this coming Saturday, November 18th, but it's really dicey. If the weather holds the way it's going tonight and the next couple of days, we'll probably have to scrub the solar observing and wait until December. But we'll have to just wait and see. Anyway, Sean will do the go, no-go call in the usual way, either on Friday night or Saturday morning very early. Dark sky, again, we have our monthly observing sessions. Dark sky at Long Sioux Conservation Area next week, first clear night of Monday through Thursday. And then the following week, we have the City Star parties at Bayview Village Park, Monday, Tuesday, or Thursday night. Again, with go, no-go calls in the late afternoon. Remind you that we still have space available at the Carr Observatory if you want to use the facilities there. There are no more supervised weekend sessions for the rest of the calendar year, and the access road will probably be closing soon. From the looks of it, if the temperature goes down this weekend the way they says it's going to, and they get hit by a snowstorm, that will probably close the road for the rest of the year, right through until next spring. So again, if you plan to go up there, basically from now until the spring, you're going to have to be prepared to park at the top of the hill and walk or snowshoe in or something like that. But we are still keeping the property available during the off season. Okay, and especially for those who are new to the center, remember that one of your benefits of membership is the telescope loan program, and you can borrow equipment from a large selection for free. You just have to reserve it with the telescope loan program online. Okay, and finally, meeting after the meeting in the usual way, we'll be congregating at the Granite Brew Pub very shortly, and hopefully we'll see a few of you there. So again, the calendars are available up front here after the meeting, and otherwise, we'll see you in 2 weeks' time. Good night.
Ladies and gentlemen, before you head out as secretary, this is the official final call for alternative nominations for the election. If anyone has one, please see me immediately. Also, if you've emailed me anything before about 4 p.m. this afternoon, I didn't receive it. So again, see me immediately. Thank you. Hi, guys. This is my David.